Another topic that relates to solutions is solution stoichiometry. It's also typically called titration. So titration is usually where we see solution stoichiometry. Remember back in the other chapter when we were dealing with reactions, we talked about stoichiometry. If I have this much reactant, how much product can I make? And the core of it was that we had to relate moles of a reactant to moles of a product using the coefficients. Same strategy. The part that's different is that before we found moles usually using molar mass. You usually had grams and you convert it to moles using molar mass. But we also now that if I know the molarity of a solution, if I have a solution, I can't divide by the molar mass. If I have a solution, I don't have just one substance. I might have NaCl and water. So I don't know what I can't use that molar mass because it wouldn't work. I can know the molar mass of the water, I can know the molar mass of the NaCl, so I can't use mass divided by molar mass. When I'm doing solutions, I want to know moles of solute is equal to molarity of the solution times the volume of the solution in liters. So I'm going to use, that's the core of the problem. All right, so it's the same, except when we do our conversion, it's moles is equal to molarity times volume, and the volume has to be in liters. For example, how many grams of AgCl can be made from 30 milliliters of 0.150 molar CaCl2? I'm going to need a chemical reaction, right? Okay, here's my chemical reaction. So I'm seeing this. Calcium chloride reacts with silver nitrate, 2 silver nitrates specifically, to make calcium nitrate and 2 AgCl. This is asking how many grams of AgCl, so I want to know how many grams of product can I make from 30 milliliters of 0.150 calcium chloride. So they're giving me volume and molarity of calcium chloride, which again, if I see this, molarity times volume, it's really telling me enough information to calculate the moles. And I know that when I see this, however many moles I have of this, I'm going to have twice as many moles of AgCl. Which then, if I knew how many moles that was, I could actually figure out the molar mass and then multiply by that to find out how many grams. So that's the strategy. Remember, step 1, get a balanced reaction. Step 2, identify your given and your unknown. Well, in this case, the given is calcium chloride. The unknown is silver chloride. Step 3, convert your given into moles. So I'm going to focus on getting how many moles of calcium chloride I have. So moles of calcium chloride is that's what step 3 means. Step 3 from my stoichiometry steps from chapter 7. Molarity times volume, in this case, 0.150 molarity times 0.0300 liters. You note that I had to convert this 30, it was in milliliters, I have to convert to liters. I get 0.00450 moles. Now how do I get moles for molarity in liter? I could take this capital M and change it out. It's equal to being moles over liters. If instead of molarity, this was moles over liters, the liters cancel and I'm left with moles. All right, now I'm going to convert from my given to my unknown using the coefficient ratio. So I have 0.00450 moles of calcium chloride. Since I'm starting with moles of calcium chloride, that's what I'm putting on the bottom of my conversion factor. I want moles of silver chloride, so I'm putting moles on the top of the conversion factor, and the numbers here are supplied by the coefficients. 2 on top with AgCl, 1 on bottom with calcium chloride. So with double the number of moles that I now have 0.00900 moles of silver chloride would be made. Now I just need to figure out how much that would weigh in grams. So I'm going to convert moles to grams. I'm going to have to calculate out the molar mass of AgCl by adding up the molar masses of silver and chlorine. And it's 143.4 grams per mole. 0.00900 moles of silver chloride. Since this is moles, I'm putting moles on the bottom. I want grams on the top. And when I multiply through, I get 1.29 grams of silver chloride possible from calcium chloride. Now, I also could ask you about what would be if it was aqueous product instead of this solid product. If this was an aqueous product, I could ask you what would be the molarity of the solution that I would get. Because again, once I have moles, I can use it to find grams, or I could use it to find molarity. So I have a couple of strategies for these problems. A couple of different ways the problems appear, but it's the same thing as we did in chapter 7. The only difference is that I'm finding moles using a different formula because we're talking about a solution. That means we really need to be thinking, which mole formula do I need? You've gotten very used to using moles is equal to mass divided by the molar mass. And that works great when I have a pure substance. But when I have a solution, I don't really know the molar mass of the solution. So I'm going to have to use moles is equal to molarity times volume in liters. So be thinking, which mole formula do you want to use when you have these problems?